All right. Well, good afternoon or good morning, depending where you are. Everyone, welcome to our second webinar from Customer Value Partners, speaking on our Hopper DevSecOps solution. Just a few announcements, three particular announcements. One, we are recording this and it will be up on our corporate website next week. Two, there are questions and answers available. So please use the Q&A feature and we'll be answering questions at the end. And third, there will be a webinar survey coming your way soon, and please fill that out because that helps us improve the way we do webinars. So we appreciate that. So let's get started. So first thing, who are we? My name is Fakir Ahmed. I run our technology modernization practice. I'm an executive director with Customer Value Partners, and I really focus on all things application development, cloud, DevSecOps, containers, Kubernetes, architecture. My group helps make sure we're building all the right reference architectures, sourcing good candidates for projects, helping with delivery, business development, pretty much everything and everything that touches all of our projects. And I'll hand it over to Kevin.
Yeah, thanks. I'm Kevin Raymond, lead technologist here at CVP, and pretty much an IT generalist at this point. Get around to all kinds of different stuff, automation for infrastructure, application development, acceleration, open source adoption, virtual reality, all kinds of stuff. So I love to make things easier for people. So hope a lot of what we see here sort of leads down that path.
Awesome, thank you. So for those of you that joined us a couple weeks ago, this will be a little bit of a recap, and then we'll get into a different set of technologies and demos that relates to that. So last couple weeks ago on the 29th, I believe, we did an overview of the Hopper DevSecOps solution, and we demoed the infrastructure setup, taking an empty AWS cloud environment, and then with our infrastructure scripts and tooling, in 45 minutes building up our entire platform. So I'll run through that a little bit, and then we'll hand it over to Kevin for some more in-depth DevSecOps app dev demos. So first, a little bit about CVP. Who are we? We're a consulting company. We're all about helping clients navigate change. We know that all the applications and all the technology solutions and all the delivery aspects that we build today are really not going to be relevant in a year, 2 years, 3 years. We know that things are changing so fast with technology adoptions. We have Gen Zers that are now entering the job market, graduating from college. We know there's a lot of expectations on technology and technologists to be very fluid and agile. And we help our clients change that way through change management, but also through the way we deliver our technology solutions. And Hopper is one example of that. So who are our markets and what are our practices? So first of all, starting in the middle, our core markets run, you could think of them running vertically, where we have national security, government health, and our different civilian agencies, FedCiv. And on the horizontal side, we have our practices. We have our healthcare consulting, business transformation, technology modernization, data science, and cybersecurity. So what does that mean? Well, healthcare consulting is not really technology. It's more about healthcare informaticists, healthcare SMEs, policy analysts. Business transformation is all about management consulting and user-centered design. Technology modernization, which is my practice, we just talked about. Data science is all about data analytics, ETL, big data projects that help us do machine learning, artificial intelligence at scale. And cybersecurity, which is really the foundation of everything we do, not just NIST RMF adherence, ATOs, but really helping build secure cloud environments, secure cloud architectures, and helping with training for our teams to make sure that as we shift left with cybersecurity, we're starting with the developers and the designers before we even write a single line of code. Founded in 2003, headquartered in Fairfax, although these days we're all headquartered from home. We have about 500 employees. So let's get into the meat of where we came up with Hopper and why we built it. So what are some of the key challenges technology executives face today? So some of the biggest are consolidation, standardization due to sprawl. One of our of our biggest clients today said, I have over 100 different application development teams building applications in 100 different ways, deploying it to 100 different endpoints. I have no idea how to standardize this. I have no idea how to make sure they're all adhering to software delivery and security best practices. I don't know how to create continuous ATOs at scale for this. How do I actually just put my arms around this and make this work? We also know that there's a lot of manual steps, a lot of human steps, unfortunately, in the software delivery process, a lot of friction, as I call it. So instead of automating your way to through the whole delivery pipeline in secure, high quality fashion to production several times a day, you have rigid human steps involved. And that's one of the reasons we came up with Hopper, was to how to eliminate those things. How do we improve the velocity and quality? We're also helping our clients migrate, not just from the data center to the cloud, but also how to get away from expensive COTS products. And how do we make sure that we're building, very portable, secure workloads? So what are the key executives' goals that help adhere and solve those challenges? Well, speed to market. Every technology executive wants to get their products, their services out to the market, either internal federal employee users or external clients, which are the citizens. At the same time, how do I reduce costs? We know there's ever shrinking budgets, especially in the federal government, and especially with 70 to 80% of your budgets just focused on O&M and keeping the lights on. How do you use that 30, 20% left to really accelerate and innovate and help you scale out your solutions and hit your goals? And also at the same time, how do I improve quality and improve security and not degrading at all? You got to keep your baseline for where you are today and constantly improve day to day, year over year. So a lot of really tough challenges and really high expectations with these goals. Really difficult to do. And that's where Hopper comes in. So before I get into what Hopper is, I want to talk about where we came up with the name. So over the last 18 months at CVP, we've been naming all of our solutions after famous women in STEM, science, technology, engineering, mathematics. And we came up with the name Hopper, named after Grace Hopper. So who was Grace Hopper? She's very, very, very interesting, admirable person that once we learned her history, we said, hey, that's the perfect name for our solution. So Grace Hopper was a rear admiral in the US Navy. She had to fight her way on every step of her career. She was a female technologist in a heavily male-oriented society, and it was hard to get her voice heard, but she worked tooth and nail to get her ideas across. She came up with the idea that programming languages should be using English words instead of these esoteric, assembly type terminology. It's hard for people to understand, hard for people to train. And then we can't scale out and build up teams and teams of technologists coming out of college. She coined the famous term debugging. There's a famous story where she was working on the big IBM Mark II computer at Harvard University post-World War II in the 50s for the Navy. And this was the days when the entire computer takes up an entire room, and they were trying to run a simulation or run an application, and things were failing. So they actually had to physically open up the hardware. And when they looked inside, they saw there was actual moth interrupting the operation. So they took out the moth, and she said, we're actually debugging. Hence the O in Hopper shows the no moth. So what is Hopper? Hopper's our managed platform as a service. It's an intelligent, self-healing, automated infrastructure. So what does that actually mean? Well, at CVP, we've taken years and years of our experience building applications, testing, deploying, automating, utilizing the scale of the cloud, infrastructure as code. And we said, how do we put all of this together? A nice, neat, easy to use package. And that's essentially what Hopper is. I call Hopper our software factory in a box. It's your software delivery platform. And what do you get with Hopper? Well, and what we showed 2 weeks ago, and you could still watch the video that's on our corporate website or on YouTube. And what Kevin demoed was essentially you take an empty cloud environment, AWS, Azure, Google, doesn't matter, or even any VMware-based data center. And through our tooling and our infrastructure as code scripts, we stand up STIG-hardened virtual machines utilizing Packer, and those could be customized for any agency's needs. and we deploy a Kubernetes cluster on top of that. In this case, we utilize OpenShift from Red Hat, which is the Cadillac of Kubernetes distributions. And that Kubernetes cluster is utilized for containerized management, orchestrating containers at scale. We build our applications to be loosely coupled microservice-based containerized applications. So some of our starter kit applications, which we'll actually run through in the demo, they're already containerized. We show our clients how to use containers, how to deploy them utilizing some pipelines as code, pipelines out of the box, and it uses a variety of tools. So what the demo showed a couple of weeks ago was once you have your STIG hardened VMs, you deploy your cluster, and within that cluster, you get a bunch of tools. You get SonarQube, which is an open source tool used for code scans, code sniffs, just checking the quality, and also some security scanning of your code. We also deploy Jenkins as a container, and that's where you could deploy your pipelines at scale and deploy build agents as needed on the fly. They're ephemeral. So for every pipeline that comes through, we spin up a container with a Jenkins build agent, do all the steps, build, test, deploy, and then tear it down. So saving you cost. And then also Splunk for utilizing all of the log output and becoming a log aggregator and building a lot of dashboards. We also showed that you could swap out Splunk if you don't want to pay for that expensive tool and use some open source tools like Prometheus and Grafana. We also have a bunch of other different containerized solutions for distributed tracing, which we use Jaeger, which is another open source tool. And we also have the Elk stack for Elasticsearch, Logstash, and Kibana for utilizing and indexing lots of logs and creating nice visualization. We also showcase a bunch of other tools in our coder catalog, which Kevin's going to show a little bit for automated testing, for security testing, and for doing post-deployment feature testing and penetration testing. So the nice thing about Hopper is these are all interchangeable tools. If you don't like any of these things, you could swap them out, and they're easy to do because it's infrastructure as code, and we have different permutations of these. So if you don't like OpenShift, and you want vanilla Kubernetes, or you want Rancher Federal, or if you want VMware Tanzu in your data center, if you want EKS, the managed AWS version of Kubernetes, or the corresponding and analogous versions in Azure or Google Cloud, those are all things we could swap out with code. It makes it nice and easy. We also talked about a few machine learning models that you get out of the box with Hopper as well. We're not going to talk about those today too much, but they do help improve development quality, productivity, and anomalous log detection. And that's something you get out of the box. And we're always cloud first, cloud native. So while I say we could deploy these things to the data center, we would actually prefer to do these things in the cloud. We utilize different scripting tools like Packer, Terraform. We utilize Ansible. We utilize different tooling that is Kubernetes specific, like operators and lots of YAML files across the board for configurations and declarative infrastructure management. And we like to use managed services wherever we can. But again, there's no one size fits all for any customer. We just like to showcase a lot of different options. And then when we sit down with clients, we actually talk to them. What are their needs? What are their approved technologies? Which cloud environment are you most comfortable with? And then we could configure the solution and launch it within 45 minutes, an entire software factory in 45 minutes. So what are some of the things you get with Hopper, that Hopper infrastructure, that service catalog, some starter kit applications and starter kit pipelines? Well, to do this all from scratch, very, very labor intensive. You know, you need experts in Splunk and the cloud and OpenShift, and it takes a long time to architect it, put it all together and configure it. And then you have to script it all so you could stand it up very, very quickly. So think about your disaster recovery environments or architecture where you want to be able to stand this up instantaneously. We could do that for you and have it done in 45 minutes. Infrastructure drift, snowflake configurations. These are things as developers we hate. Hey, it works on my machine, but it doesn't work in tests. Well, you're using two different versions of Postgres. Why are you doing that? Well, my JVM here is different from your JRE over there. So we want to make sure that we're building and deploying the same consistent tech stack wherever we go, including the infrastructure. And we could do that with infrastructure as code. Talked about our service catalog. We have a lot of starter kit applications, open source applications, reusable frameworks that we've taken from our different programs, and we make those available at no cost to all of our government clients. Interchangeable security tools. We talked about SonarQube for static code scanning. You could also add HP Fortify. We utilize different container scanning tools at build time like Twistlock or Claire. And then also post deployment, we utilize Sysdig Falco for runtime container scanning. Think about that as your anti-malware that's always running on your laptop. We help stop and reduce delivery productivity waste through our machine learning models. It's really about helping our development teams improve their estimations during sprint planning, and also helping to make sure they're deploying more secure applications and less buggy code. And again, cloud native, cloud first. So I'm almost done talking. Now I'm going to hand it over to Kevin for the fun stuff. So what is the demo that we're going to show today? Well, this is one demo. Kevin has a lot of things up his sleeve. He always likes to go above and beyond. But the first demo is really, really basic. How do we build on the Hopper infrastructure that I just talked about, right? Stig hardened VMs, Hopper, OpenShift cluster, Kubernetes managed, SonarQube, Jenkins. How do we Splunk? How do we utilize all these tools? Well, you'd have to build an app, you'd have to build a pipeline from scratch, you'd have to integrate all these things. That takes a lot of time as well. So what we do is, once you deploy the infrastructure, you could pick any of our starter kit applications, and those come with starter kit pipelines. So in this case, we have a Node Mongo basic application. And what Kevin is going to show is our service catalog. And when you deploy it through our service catalog, it's really getting all the Jenkins Groovy pipeline scripts and some YAML scripts to help deploy that and integrate into the Kubernetes cluster, which is Hopper. And then the Jenkins manager, which is always running, will spin up a dynamic build agent. We'll see that get spun up and destroyed, and that's going to build and deploy the stack. So I'm going to stop now sharing. I'm going to hand it over to Kevin for the fun stuff.
All right, thank you. Let's get started. Let me arrange some stuff real quick. All righty, so what we're looking at now is our coder catalog, an ever-growing collection of easy to deploy stuff. That's sort of the goal of this. We're not going to spend too much time in here, but we will see how it works with this demo app. So I already have a Hopper cluster sitting over here up. That's what we did in the last webinar. So this is showing you a Jenkins master, and that's the only thing that exists right now in here. What we're going to do is deploy this one. So for this particular application, we need only 3 pieces of information to deploy it. We need the kubeconfig location that tells coder how to connect to the cluster where it's at. And then we just need to put in our username and password for authentication. That's all we need for this one. So this is going to go real quick, and then we're going to swap off of here so we can see what's happening inside the cluster. All right, so that is it. Super fast. What that did was created a build configuration pipeline here, which we can see, and that also started this pipeline running. So what this is going to do now is create the I'm too slow. This created the Jenkins build agent. In this case, it's for Node app. And what's going to happen now is it's going to take the source code from repository and build it on that app and deploy it. So this is visualizing the Jenkins pipeline behind the scene, and we'll take a look at that in a minute. So right now, already the build configurations will be there. So here we go. We have our MongoDB, and this is our application. We can see that the build is running. If we open up the URL right now, we're going to get that it's not available. So as soon as that's ready, we will refresh the page and take a look at that. So in the meantime, let me go back over to the pipeline real quick. And I can show. So we'll see what it looks like in Jenkins. So if you've seen Jenkins before, this is just your typical Jenkins output. And what you've probably seen this many times if you're familiar with Jenkins, just the stages views. So it's actually completed at this point. Each of the stages, the create one created the deployment configurations. Build was actually building the container image from the source code. And then after it was deployed, we tagged it and put it inside the internal image registry in OpenShift. So if we go back to our app page and refresh, there we go. Nothing super fancy. This was just to show, here's a Node app deployed. Here's the MongoDB URL. There's no interaction with it. It's just showing that it's connected to that. So what's good about this now is we can go into our source code and let's see if I can pick the right tab. There we go. So we can go to the source code here and make a change like you would. And now that Coder's already deployed this, everything is already set. So we don't need to touch Coder anymore at this point. We can just make a change here. Let's do, we'll just change this and make it large. And I'm just going to commit it directly to master so we can get that change happening here. Now if we swap back over to the pipelines, we'll see a new pipeline's already been started, and it's going to go through that same process again, where it's going to spin up that build agent. We missed it going down, but we'll leave it here for a second. Once it's finished being used, it'll tear that agent back down, so it's all dynamic, so you don't have to have anything running all the time. Once we get this, in this case, this is just a simple demonstration app, so it's going to actually remove these things. In like a real app or production app, you'd have a rolling deployment where it would leave the current application running, then it would spin up the new version, the new pod of the application, and then it would destroy the old one. So you would have zero downtime with something like that. And those are just things that you can configure along the way here. So the MongoDB is back up. And we'll give this a moment here. While it's doing this, a reminder that the Q&A is open. So if you see anything that you want to ask a question about, type it in there and we will get to it as soon as possible. All right. It always goes slow when you want it to go fast. All right, here we go. Build's done. Image is coming back online. There goes the build agent. Bye-bye, build agent. And all right, so we go back to the app, refresh, and there we go. There's our change pushed out. So it's real straightforward to get this done. And now you're probably like, well, this example doesn't really show anything, and that's true. This was just a simple one, just to demonstrate something easy. You could use this as a developer, could easily kickstart something in an application, whatever the technology stack is. It's very flexible and interchangeable. So this was a simple example. Now I don't have this encoder right now, but we can look at this application. This is a GitHub application that is deployed on JBoss Wildfly open source server. This is JAX RS RESTful web service. This just interacts with the pod that it's running on, just to demonstrate that it's working. We'll throw some logs in there. I'll just click a few of these, and this is just showing how the API works as a demonstration. So you can see all those log things popped up here as I clicked them. So what's cool about this one is how it gets here. The whole entire, well, not the whole entire, most of the development or the deployment stuff is in here. So let's take a look at it. This is a bit more complex than the simple node Mongo one we have. So we'll go through this here. GOGS is a Git repository, very lightweight. So we have the GOGS application itself and the Postgres database to hold the repository that's running inside this project. We have our SonarQube server for static code analysis. We have our Jenkins master. So this is another Jenkins master inside this specific project. And then we have Nexus, which we'll use for the application artifact storage. That's the WAR file that will get generated when we do the build. We'll go over to this build pipeline, and it's similar to this. So this one is more like what you might see in a typical Jenkins setup right now. If you have Jenkins, typical stages. So we have build. We'll just go through this real quick. We're pulling the source code from that GOGS repo, and we do a Maven build. So it's gonna spin up that build agent for Maven this time instead of Node automatically. We do some JUnit unit testing in there, which will show up. And then we kick it over to SonarQube for static code analysis, code smells, some different security type things. At that point, we're going to send it to Nexus as the WAR archive file, ready for deployment. From there, we're going to take it and actually build the container image for deployment into dev. So in this case, we have a dev environment, which was a dev project, sorry, which we just looked at. And that'll actually be able to be promoted to staging, but that's a manual gate. So we'll have to go in there and say yes. In addition to that, we are going to send this to the Quay.io image registry, which is a Red Hat registry that includes Claire, the tool Fakir mentioned, and that's used for static container image scanning. So we'll get to take a look at that. And then we'll go ahead and promote that to the stage environment. So let's kick this off. Let's try that again. So in this case, I'm just manually starting the build at this point, so I don't have to make a source code change. While it's doing this, we'll just show off one other thing that's in here. You can actually even put your Eclipse IDE into the cluster. So your full development environment, IDE and everything can be all in the cluster, sharing resources. So you're not having a bunch of, EC2 instances running, for example, or something like that. Lots of the things here use OAuth. So it's using the OpenShift credentials to log in. This stuff is all, normally you would see a bunch of stacks for things you could create or stuff like that. I don't have the certificates set up, just self-signed certificates right now, so it's not loading those things. This is just to show, this is just another option just to throw into that. So not only do you have the deployment capabilities, but you can actually do your development in a Kubernetes native fashion. Oh, let me go back there. We can see. So there's that Maven build agent that the Jenkins master spun up for us. Now we'll take a look at this build. And again, you could look at this in Jenkins the same as we did with the other one. You can see here, this specific pipeline build strategy, Jenkins, is deprecated in this version of OpenShift 4. There's a new open source, fully cloud native Kubernetes pipeline option called Tekton. We're not going to take a look at that today, but perhaps in the future we can have another webinar. Certainly we'll have some demos or something about it in the future. If you're switching over to something like this, sometimes you just have to say bye to Jenkins, right? So if you have already existing Jenkins pipelines, you can see that you can migrate it over, but it's much easier to just take advantage of the new stuff here. It's 2021, so that's many benefits to switching over to that. Let's see here. Still doing the build. And while we're looking at this, we'll just look through here a little bit. So you can see all kinds of different information in here. You can also, we can look at monitoring of the specific project. So you can see here, we started our build. So all the CPU usage is going up. A lot of different ways to monitor based on your project, based on just the specific pods that are running, and pretty much any combination of stuff in there. So actually, now that the build has passed, let me get back here. There has to be a shorter way. I'll figure it out. So, okay, we're actually up to the promote to stage. So this will show a little pause button shortly, and we'll click on that. That'll actually go into Jenkins to promote to staging. Oh, there it is. So let's do that. I have to log in. All right, and this is a Jenkins feature, the pause. So we just say promote, and now it's going to finish that build pipeline. I'm going to close this. We'll see it finish in this build pipeline here, and it will promote to the stage project. There we go. So now that full pipeline is done. You can see the stage project real quick. There it is. It's spinning up. This is actually doing a rolling deployment. You can see right here, I got it in time. There's the currently active pod. This new one is this new container is being spun up. And then once this is up and active, this other one's going to go away. We don't need to sit here and watch it. That's what it's going to do. So let's go back here real quick. I want to look at I want to show the different stages that it went through in this pipeline. So first, we had the build and the unit testing. That was in Jenkins. Then we sent our stuff over to SonarQube for static code analysis. Let me find that one. So there we go. Let me refresh this page. You can see. So here's our last one. Passed for now. Definitely could use some better test coverage. SonarQube does a lot of good stuff. Code quality smells. It's very configurable. It supports many languages. You can even, they've added in more stuff lately. You can check out security hotspots, specific things that are flagged. It links to CVEs. There's tons of information as far as how to fix it. It will automatically flag and create different issues and different things. So there's code smell. You can get OWASP zap type stuff in here. There's all kinds of stuff that you can, scan the source code for. And this again is just static source code analysis. After SonarQube passed, we package up the source code into the WAR file, and that goes into our Nexus repository. We can show that here. That is in the snapshots for Maven. And here it just drills down the artifacts for this build. So nothing very exciting in this one. So let's go to the next one. We have, yes, so the only thing that's not in the cluster right now is the Quay.io repository. So take a look at that. And this is, you can sign up for free for this even and do this with your own container images. This is the task app that we built. And this is a great tool that Red Hat has provided. So we can see, here's our two tagged images. We can see there's lots of security vulnerabilities. If we look in here and drill down, it'll show you the CVE links. It tells you what package it's in. It says, even which layer in your container image introduced this vulnerability. So a lot of information as far as, being able to remedy things and deciding what you want to fix. Whoops, let's see. So that's it. Yeah, after the Quay repository and that gate, we went over to the staging. This should be finished up by now. Yep, so that's there. And just to show, now it's just stage instead of the dev environment. That's kind of small up there. That's a stage. And it's the same thing. So that's it. That was the whole pipeline through 2 different environments, static code and container image analysis, packaging it up based on the Jenkins pipeline. And that's it, super easy. So I can't make the code change right now because this Eclipse thing won't load But if you made the code change similar to how we did that first node Mongo demonstration, that would then kick off this same pipeline again in here in the CI/CD area. It'll do this pipeline and create a new build, and it's just repeatable from there. So it's pretty good. Lots of the stuff that makes Hopper, not just Hopper, but the underlying parts using Kubernetes and stuff. Since it's declarative, you can go in and mess with stuff, and you can say, I want to, let's use this as an example. Let's say I want to delete the Jenkins master pod because I don't want it. So what's going to happen is, you see already, it's already created a new Jenkins master pod because the deployment configuration said, no, that's supposed to be there. So it's putting it right back. Now this one's an ephemeral one. So if we looked into there, we wouldn't see any of the build history. But you can also create one that use persistent volume storage, in which case you would be able to keep that, a file share basically in an EBS instance in this case, since this is hosted in AWS, and then restart the server and it will reattach to that, so you wouldn't lose any information. I think that's all, really.
Awesome.
It's pretty
Thank you,
straightforward.
Kevin.
Yeah, no problem.
Great set of demos. So again, 45 minutes, you start with an empty AWS account. You get your full software factory in a box, configuration, all infrastructure as code stood up, and then some sample applications. You're building, you're deploying, you're doing code smells, you're doing container scanning for security holes, unit testing, everything, all done in 45 minutes. I mean, that's pretty powerful and a huge accelerant for our application teams. And I know our development teams are appreciating just that kind of set of tooling and power that they have at their hands. So let's take a look, and we're done with the demo. Let's take a look at some questions. Let's see. So is Jenkins the preferred CI/CD tool? Great question. I know Kevin touched upon this. I know Jenkins, or CloudBees, which is the paid version of Jenkins, a lot of our government customers, or even in the commercial sector, they're very familiar with that tool, and we could definitely utilize that. We have no problem with that. We could use Argo. We could use Travis CI, the managed service offerings from AWS, Azure, Google. We're as we are cloud agnostic and Kubernetes agnostic, we're also build tool agnostic. However, we are starting to transition more to Tekton, which is an open source project. It's 100% cloud native. It's a very powerful Kubernetes native open source framework for building CI/CD systems. Essentially, you could do all the same things you could do in Jenkins. You could build, test, and deploy, but across multiple cloud providers, or even on premises. So it doesn't even matter. You're abstracting away all those underlying implementation details, and all the pipelines run in Kubernetes, and they utilize Kubernetes clusters as a first-class type, and utilize containers as their building blocks. A few different things. So those are all YAML configurations instead of your Groovy scripts for Jenkins, but you could still store them as infrastructure as code in a Git repo. So another question: does Hopper in these tools create vendor lock-in? So absolutely not. Like we mentioned, it's all infrastructure as code. We have different configuration options. There's not a one size fits all for everybody. So we make sure that we could swap out Kubernetes cluster options. We make sure we could swap out different CI/CD tools and pipelines. We have lots of different starter kit applications in Java, .NET, Node, and different open source frameworks that we could deploy for our clients, all within the click of a button. All right, let's see. How can Hopper help control cloud spending? Okay, great question. So since we utilize our coder service catalog for propagating and deploying, that's our central point of provisioning. While you could use all the scripts offline or do it yourself, we like that model because we enter financial information or cost, and we have a lot of governance set of tooling. So within Coder, if you want to just click and deploy something, you actually have to have the right permissions. You have to make sure when you're deploying something, we actually give a cost estimate. Didn't see that in Kevin's demo, but that's a feature that we're working on right now. And if what you want to deploy goes higher than your cost estimate, or if the cost estimate is higher than your budget, it won't let you deploy anything. It'd be nice to spin up 1,000 Hopper clusters, but that does have real cost, even though you could tear them down very quickly as well through Coder. But we are making sure that we're protecting that spend for all of our clients. Let's see, other questions. Do we have any existing clients using this? Very, very good question. So it's not just vaporware. We are actually using this with a couple of our federal clients, and we are using components of it. And we do have this at one client that's actually deployed end to end, the entire infrastructure and set of tooling, and they're actually a .NET shop. So we're utilizing .NET Core containers on Linux STIG hardened VMs. And we're implementing all the CI/CD pipelines for them and making sure it's all nice and secure and high quality. Let's see. Kevin, why don't you talk to us? Someone's asking about what this GOGS thing is. Could you just maybe highlight what GOGS is, lightweight Git, how do we deploy it? How do we utilize it? Why would people use it? Maybe walk through some of those.
Yeah, sure. Let's see. We can even go look at it real quick. Let me reshare. And that's not right. There we go. Yeah, so GOGS is, if you GitHub, GitLab are, big popular ones. They have lots of stuff, issue tracking, workflows, all kinds of stuff that you can do, CI/CD built-ins and stuff like that. So GOGS is actually a nice and lightweight Git repository, and that's all that it does. So this is it. So it's very lightweight. You can put it, you can see it's running in the cluster. It's very low on resources. I feel like you could even, I think it can deploy like on a Raspberry Pi even or something. It's very non-resource intensive. So this is actually the repository that we pulled the task app from that we looked at. So this is just living in here. It's good. In this case, it just keeps everything in one place. You could have, essentially a different repository for each project, for each, developer. I don't know that you would want to do that, but you could. So it's nice to be able to move it around when you don't need to worry about, like GitLab. We have GitLab, which we saw first in that first demo at CVP. But that's a big, big installation that's running, and if you just need a repository for something, you don't want to have to throw that up and go through all the installation. GOGS installs real fast, and it can go basically anywhere. So it's definitely a good choice for if you only need a repository. It's the best. It's the best way to go.
All right, looks like there's another question. What is the difference? And I'll hand this over to you, Kevin. What is the difference between the green circle and blue circles? I'm assuming that's part of the OpenShift UI.
Oops, that is not what I meant. Let's do that again. I want to go back there. Like these. So yeah, a lot of OpenShift, this is the OpenShift interface, which is they make it visually pleasing to look at, and it depends on what you see. So this is actually a job that was run, and the green there indicates, if we can highlight on it. So that's successfully ran that job from start to end. So there's going to be that one. Blue means that you have stuff running. If we do that, if we throw this down again, sorry, Jenkins. Let's see if I can get back there quickly now.
What is your hatred of Jenkins? You just keep killing it.
So you can see it like this. Here's one's pending, one terminated. So they're just different status, and you can hover over it and it'll show you. And it'll just change. Lots of times when you see, let's see if there is other instances will be, there'll be like a ring on the inside for a rolling deployment that'll show like the new pod, the new container engine being created and spun up, and then the outer one will go away and it'll sort of swap. So it's just feedback indicators as far as what's happening. I don't really like them because I'm pretty colorblind, even with my cool colorblind glasses on. But that's why, you know, I can just hover and I get over it. So, but that's just feedback for different things that are happening, and there's different, you know, shapes. So these are applications that group certain things together. Like in this case, Gogs has a Postgres database that goes with it to do all the storage. Another one we could look at is, here's a cert manager one. So this actually looks a little bit different because this is a Helm chart that deployed these things. So this is just the different ways that OpenShift specifically visualizes certain things. They do a pretty good job with that. So I like how it looks most of the time.
Thank you, Kevin.
Yeah, sure.
So we got another question. I think then we're almost wrapped up. How do you deal with siloed teams, development, IVNV, ops? So another great question. You know, we understand not all development teams are fully functioning DevSecOps teams. You know, they own from idea to code to test all the way to production. They own production. But what we utilize Hopper for is to help bridge those silos and to just help make the actual DevSecOps transformation or org change or cultural change for an organization a lot simpler, right? Those barriers of, you know, I'm a developer, I just work in operations. We're all committed together to helping achieve the same goals for the agency in a secure, fast way. So by utilizing containers and by utilizing infrastructure as code and Kubernetes, we allow development teams to really just focus on the business logic at hand. And then the pipelines and the Kubernetes clusters are all set up and just works. However, at the same time, because this is infrastructure as code, developers could stand up this entire infrastructure very, very quickly in their laptops or in their own AWS account or a VPC just as a sandbox. So it allows everybody to touch every single piece of the entire tech stack, including the infrastructure anywhere. And that really just helps to upskill people, helps to transfer knowledge, and it really just helps make everybody feel more comfortable with the entire thing end to end.
Yeah, and to add on to that, Fakir, there's also, you always have lots of times differences between, you know, production and the not production systems, right? So why doesn't my stuff work? Because production doesn't even look anything like what I'm working on. So going with this, containers and infrastructure as code and just defining, you know, application templates, all that stuff up front. If you use those from dev, test stage, production, whatever the environments are, you know, there's going to be small differences maybe as far as scaling or stuff, but everything will be, you know, quote, the same, which really makes it easier. You won't have any of those memes that come and say, worked in my environment, you know. So
Works on my laptop.
works
I
on
know.
my laptop.
I always hated saying that and hearing that.
I still say it sometimes.
So that's the end of the webinar. I don't see any more questions. So we're going to let everybody go and have a good rest of your Friday and have a good weekend. And again, there will be a survey coming out and this recording will be available on our CVP Corp site next week. So please feel free to pass it on to other colleagues, friends, family, children, whoever is interested. Thank you for the time.
Thanks,
Goodbye.
everyone.